probably the trickiest thing on the store item is just getting this constructor to work. So the first thing we're going to do is we're going to complete the initialization of the display. This is a new array, a new array that holds store items. And you had to read the directions pretty carefully. So this is going to take the taxable items, okay? Maybe there's 50 of them. And it's going to put all one spot for each of them. And then it's going to combine with that all of the non-taxable items. Maybe there's 100 of them. I don't know. But for every one, there's going to be a store item created. Okay. And so we need room for all of them. So these aren't parallel arrays like in the person class. These arrays are actually combining together to form one big array. Okay? And from here, what I'm going to do is I'm going to loop through all of these. Now, what I'm going to do, and this is what I would recommend, so I'm going to write two different loops. I'm going to write one loop, move through all of the taxable items, although it doesn't really matter which one comes first because the directions of the order doesn't matter. I'm going to take all of the taxable items first, okay? And I'm going to put them into my store display. And then I'm going to do it again, okay? I'm going to actually write a complete separate loop, but this time I'm going to take the non-taxable items and put them in. Now the problem is maybe I've got 50 taxable items and I've got 30 non-taxable items, for a total of 80. Well, now you've got indexes like 0 to 49 for the first array, 0 to 29 for the second array, and your overall big array goes from 0 to 79, 80 items in it. So we're actually going to need a third index. Now, you could get by without creating a variable for it. A lot of groups just did some subtraction or addition to make this work. But what I'm going to do is I'm just going to create my own index here. And then every time that I go to the display, I'll increment the index. So first up, I'm going to index 0 with my new store item. Store item constructor wants a price. This price is going to come to me from the taxable item prices. I'm handling all of those first. Okay? My loop variable I was made to access that array, but it also wants a Boolean. So I got the double from the array, but it also wants a Boolean. Well, all taxable items receive true for their Boolean because they are in fact taxable. Okay, I'm going to do virtually the same thing in the other one. Right here, but I'm going to use the non-taxable items, and that means that I'm going to give the Boolean argument a false. Now, there's one more thing. My loop is only controlling the I index, which is connecting with one of those two double arrays. The index variable that I named index is on me to go ahead and increment. So every time that I put something into the display, I'm going to go ahead and increment my index. If everything goes well, we should see some store items appear here with prices. They'll also tell us if they were taxable or not. All right, so some were true, some were false. You could go check with the constructor, but yeah, this is looking good. Okay. All right, get total price for all items. Okay, so it sounds like a total. Make sure you initialize your total here to a double. We are in fact dealing with doubles. And when we're finished, we'll return it. Great opportunity here to use an enhanced loop. Okay, so give me a store item from the display, and I want to access its price. There happens to be a get price method, and I'll use the get price method to add it on top of my running total. It was something over $100. We'll see. And then get total price 146. All right. Get total price for the non-taxable items. All right, almost the same thing, right? But we're going to have to put an if statement in so that we're only accessing certain items. So before I can automatically assume that it goes into the total, what I'm going to have to do is I'm going to have to take the store item and determine if it's taxable. So sure enough, if you check out the the class over here, there's a method called is taxable. It's going to be true if it is, false if it isn't. We actually want it to be false. So we could say equals equals false, or we could put an exclamation point, and then that would only run the if statement when it was in fact false. Let's see what happens here. Yeah, $49. That's about right. Okay. Price increase for all items. Okay. Notice that the price is encapsulated, it's hidden. So we're going to need a mutator method for this. And yeah, sure enough, there is one right here. See, increase price. You give it a double and it will increase the price. Okay. And there's a parameter that we're supposed to use to increase the price. So give me a store item. Okay. From the display is what that loop's going to do. And I can increase its price to any double value that I buy any double value that I want. And that's what INC represents here. So everybody's going to go up, I think, $3.75, if I remember correctly. And then we have two least expensive items. So yeah, see how $9.99 became $13.74. Don't worry about those excessive zeros. That happens with doubles sometimes in their round off error. So least expensive item by price, least expensive item. We could do this a few ways. We could create an indexed approach and then just change our return. Kind of a creative solution. You don't need to do this. Okay, this is just me showing off or whatever. So what we could do is maybe write this method first, and we could create our store item. So go to the display at index 0. All right, I'm going to assume that that is the least expensive item. I mean, obviously I don't really believe that, but I'm just going to act like it is. Okay. I'm going to go to every other item. You could actually use an enhanced loop here since we don't really care about indexes, or you could use an index loop. Okay, it doesn't really matter, but we're going to take all of them. Okay, and we're going to ask a question. We're going to ask if this store item has a price that's less than the other one that we're tracking. And if it is in fact less, then we're going to swap it out, okay, because we got the wrong one. And then in the end, we should return the least expensive item. Now, I was mentioning a second ago, I said we'll do something a little bit creative here. So what I'm going to do is, this said the $4.11 one, and that's correct. Yeah, see, that's the correct one. That is the cheapest one. Look at all those prices. I'm now going to take this method and call it right here. Here's a catch, okay? That gives me a store item. The method wants a double. How can I turn a store item into a double? Well, okay, I can get the price of the store item. So the first method call there actually returns the least expensive store item. And then I'm asking specifically for the price of that least expensive store item. We'll see what happens. Yeah, it actually worked. Okay, it gave me $4.11. That's pretty interesting there. This is that idea of object oriented programming where we're getting this all to kind of click together. All right.